Alright, 2.09 Definitions and Biconditionals Part 2. Just picking up where we left off with Lesson 2.08 yesterday. Don't forget to give me your course and section number with all of your communication. The objectives here is we're going to use Euler diagrams to analyze definitions. We're going to identify pairs of adjacent angles, and we're going to write a converse and a biconditional for a given statement. Good definitions. What makes a good definition? It uses terms that are clear and have been defined previously. It explains or makes obvious why the object being defined is part of a certain classification, and use as few words as possible. So we're just going to jump right into this with some examples. It says for each statement do the following. A. Write the conditional and the converse. So we have a square is a rectangle with four congruent angles. So you're going to say if a square is a rectangle, then it has four congruent sides. And I said angles just as big as I could. If a rectangle has four congruent sides, then it is a square. Ooh, I messed up that conditional big time. Now I'm going to take this conditional that I wrote and I'm going to flip it so it'll be a converse. If a figure is a square, then it is a rectangle with four congruent sides. Okay, part B says draw the Euler diagrams for the conditional and the converse. So here's our Euler diagram. Alright, so here we have we got to remember our conditional statement. If they are rectangles with four congruent sides, then they are squares. Okay? And then here's what the converse looks like. If they are squares, then they are rectangles with four congruent sides. And then what we're looking at is this is true, the conditional statement is true, and the converse is true. So remember, when they're both true, it kind of makes up a definition, which we call a biconditional. So in C it says determine whether each statement is a definition. If it is a definition, write the statement as a biconditional. If it is not a definition, then explain why not. Well, in part C, it can be a definition, or you want to call it a biconditional. A figure is a square if and only if it is a rectangle with four congruent sides. So that works out. Okay, show by counterexample that the converse of each statement is false. All rectangles are parallelograms. So let's see what they're going to do here. Here's the converse. Okay, remember, counterexample is, your converse means you're going to flip your hypothesis and your conclusion. So you're saying if a figure is a rectangle, then it is a parallelogram. So when you flip it, you say if it is a parallelogram, then it is a rectangle. Okay? Or rather, you could say all parallelograms are rectangles. Well, this picture right here is a parallelogram that is in no way a rectangle. So there we showed by counterexample that the converse of each statement is false. It says write the statement's converse and combine the two statements into a biconditional. It says if two angles have the same measure, then they are congruent. Okay, so the converse is if two angles are congruent, then they have the same measure. Let's see what we got here. If two angles are congruent, then they have the same measure. That's the converse. Now we're going to combine the two statements into a biconditional. Two angles have the same measure if and only if they are congruent. What we talked about today is diagrams are an effective way to represent mathematical statements. For biconditional statements, the Euler diagram is valid regardless of the positions of the hypothesis and conclusion within the diagram. And because Euler diagrams make it easy to evaluate biconditionality, they can be used as a test for a good definition. I will tell you that there is a question like this on the Part 2 test where you have to do the converse, the biconditional, and draw the Euler diagram. So be sure you know this information pretty well. When you get finished watching the video, you should go into Lesson 2.09, Compound Statements Part 2, and complete the study guide. Read through pages 47 through 49 in the reference guide, and then complete the following problems in your practice problem set, 25 through 33 odd. And if you don't understand anything in those practice problems, you need to get in touch with me before you take the 2.09 quiz, because we want you to be successful on all your quizzes. And that's going to be our lesson today, and thanks for listening.